So we can move now to the first module, circuit breaker monitoring. Why is circuit breaker monitoring? Circuit breaker are highly critical components to the power protection system. And maloperation of the breakers is one of the most common root cause of failure. Reliable conditions are even required after a long period of inactivity. As you can see here, circuit breaker mechanical system remain in a static state for extended periods of time, and this is not acceptable. So reliable conditions are required even after a long period of inactivity. Normally, the maintenance of the circuit breakers is performed on regular time intervals. As reported here, we could say that time 1 and time 2, we can perform some offline tests. But in the between, we cannot exclude issues or failures. This is due, for example, to the number of operations occurring between the maintenance cycles, or in some cases due to internal inspections or intrusive internal inspection that can introduce contaminants or other elements. The mechanical, you can see here in this animation, the mechanical system of the circuit breaker is consists in multiple moving parts that are normally working together, with a stored energy system to activate the physical opening and the closing of the main contacts. And this design can vary between models, but the majority of the breakers failures, both major and minor failures, can be caused to a malfunction of one or more components within this this operating chain. And it can be difficult to detect this behavior through a unique use of offline testing procedures. Talking about monitoring, so the implementation of online monitoring allows parameters to be recorded in real time, not only in time 1 and time 2, under actual and real operating condition. Then even a waveform analysis of the main contacts, trip coils, transducers is provided in order to evaluate and to understand many of the breakers' vital operation parameters, such, for example, degradation of the breakers' lubrification, integrity of the trip coils, problem in the operating mechanism, as well as slow operating times. And this offers many advantages over offline testing, because we are looking to the breaker functionalities under real working condition. Here an example of sensor installation to detect, for example, the open coil behavior. As you can see on the left, we have a schematic of the sensor installation, in this case, our current transformer, that must be put on the coil or the protection relay. And this sensor action are connected to the acquisition board. Several channels are available. And in general, and on the right, you can see an example of the current profiles that the acquisition system is capable to capture using this kind of sensor. In general, in faulty condition, the circuit breaker parameters become outside the OEM's recommendation. For example, shows deviating profiles. If you look to these profiles, for example, because they require more time to complete the changing status, or a common coil current stays for a longer time, or the velocity is lower than the nominal. In this example, the current profiles are analyzed by the system and compared to the nominal ones in order to raise an alarm if something is going wrong. For example, if the time is longer than the expected value. Or, like in this case, to detect the open and close time measurements, you have the measurement that in this case is taken through the open and close command and the status of the auxiliary contacts of the breakers. These values are needed in order to properly evaluate the time delayed during an opening or a closing maneuver. On the right, more or less equivalent to the graph you've seen before, you have on the top here the feeder current, and on the bottom the contact status for the open coil command, close coil command, and etc. Other types in this slide, you can see other types of profiles that can be acquired by and analyzed by the system. For example, the trouble movement profile. And during an event, typically a close or an open operation, an entire set of these waveforms are acquired and analyzed in order to identify issues or values in general outside OEM's recommendation. And in this case, the system is capable to calculate and raise an alarm or several alarms. Here you can see the acquisition unit dedicated to the circuit breaker monitoring. The main feature of this unit is the possibility to have continuous monitoring. If the installation is very simple, you have 19 inches rack mounted, is capable to generate and calculate automatic alarms. This drawer has a modular configuration, so you can choose the electronic boards according to the customer and the project needs. And the units has even several dry contacts embedded. The main parameters that we can handle with this unit are listed on the right. We have the breaker status, the open and close time, the pull discrepancy, full current profile, and I square T, the profile of the current of the motor, peak or the full current or the motor current, and other parameters that are essential to understand the health status of the breaker. Other measurements are available according to the configuration of the unit. For example, we can acquire even the battery voltage or the DC power supply voltage, even the heater current. In the same system, we can even integrate SF6 density measurements and calculate alarms like remaining days to refill or lockout. The data acquired are processed locally and can be exported through several digital protocols, but even through the embedded dry contacts. In this picture, you can see the three major parts of the unit. On the right here, you have the analog and the digital inputs that are connected to the contacts or the sensor. We have the dry contacts here that can be connected directly to the substation SCADA, or the fiber optic and the power supply part to be connected to other system, to other subsystems, or to the central units. Here, a schematic showing the connection of several acquisition units. In this case, are installed close to the local the LCC. And the fiber optic in a double ring configuration that connect each acquisition unit to a central unit. Here you can see two different types of data visualization. The COM tray here on the left, where you can perform the waveform analysis, and for example, and on the right, the information relevant to alarms and trends that are available on the centralized software. As I said, measurements and alarm can be also exchanged with a third party, SCADA, with, for example, IC61A50, 104, DMP3, and other protocols that are available on demand.